Hello, everybody, attending this virtual session about LLMs in practice. So my name is Ville Tuulos. I'm a CEO co-founder here at Outerbounds. I used to lead the machine learning infrastructure at Netflix. And Eddie, do you want to introduce yourself?
Yeah, hey everybody. Thanks for attending the session. Looks like we already have 65 folks. That's awesome to see. My name is Eddie. I've been working with Outerbounds and on the open source Metaflow project for a little over 1.5 years now. Prior to that, I was working at other machine learning startups at Intel briefly, and generally kind of been in the machine learning computational science space for the better part of the last decade.
Now, the topic of this workshop is LLMs in practice. And of course, I know that this is the MLOps World Generative AI Summit. So I believe that probably everybody here has some idea what we are going to talk about. And actually, what's quite exciting about this workshop is that this is going to be very hands-on. So you will be able to do many of these things at home and follow along. And Eddie will be talking more about how you can do that. Actually, you will be able to do that in your browser. You don't have to install anything locally. So that's going to be fun. But although I believe that many of you here are probably already quite excited about AI, Gen AI, and LLMs, I thought that it might be fun to spend a few minutes here in the beginning, just to kind of maybe share a bit of a vision, like what we think, where the world is going, and then of course also motivate what we are going to talk about here, and especially the angle and the approach that we are taking. So anyway, I mean, this is a long way of saying is that bear with me. I will talk for a bit, maybe a 10-15 minutes in the beginning. This will be a 2-hour session, but I mean after that, you will definitely get to kind of do all these things in practice. So we'll be very hands-on. But let's start with the motivation. So what you see here is an e-commerce store, 2014 era. So nothing too remarkable here. I'm sure that many of you have seen many e-commerce stores like this before. So what you see here is that, of course, you have some products, in this case, couches, sofas that they are selling. And then on the left-hand side, you have different filters. So you can choose the material, cotton, you can choose the price range, you can choose the color, and so forth. And now, this is, of course, exactly what the very kind of a mainstream e-commerce shop has looked like for now pretty much a decade, if not more. And you can imagine that in order to implement a system like this, what happens behind the scenes is that there's some kind of a database, a relational database, and then you have obviously this web interface, and then when you click here, a different filters. You can basically imagine how the corresponding SQL query gets constructed on the backend side. You can imagine that we run this query that color equals red and material equals cotton, that the price range is more than $1,000. And then we run the query against the database, and then the database returns the results. And then I guess the really big innovation about the World Wide Web is that now we can show these images, and we have these beautiful images here. But I mean, at the end of the day, it is kind of a very 1970s style database interface, kind of a glorified with the pretty pictures. And now, if you kind of fast forward to today, this is actually the very same store today, and there are some similarities, some differences. Well, I mean, one obvious difference here is that the photos are bigger, so we have more bandwidth available today than we had about 10 years ago. So we can afford having a higher resolution images here. But at the end of the day, the interface is still similar. So you still have the same filters here at the top. You can choose the color, you can choose the fabric, you can choose all these things. And I'm pretty sure that the implementation on the backend side might be roughly the same. We run the database query and so forth. Of course, probably the JavaScript framework has changed 15 times over the 10 years. But I mean, by and large, I mean, it is still following the same a database retrieval pattern. Now, what is of course so very exciting about where the world is going, and if you kind of extrapolate the trend, you can kind of see a few things happening almost inevitably. I mean, one thing is that if we just imagine that the photos will be getting bigger, I think it's pretty obvious that at some point we will get to the point that we can get rid of all this additional Chrome and the interface, and we can really focus on what matters. And you can imagine that an interface like this, let's say in 2026, this might be a bit optimistic, but I mean, let's say over the next 5 to 10 years, is that it really reflects the kind of a showroom experience what you would have if you went to a physical store. And now if you imagine that like you went to a physical store, there would be probably a salesperson like coming to you and like showing maybe like one of the pieces of furniture at the store and asking that, oh, well, I mean, is this, for instance, like what you had in mind? And now it might be so that like you could tell the salesperson that, no, actually, like I want the pink sofa. And now the salesperson like would maybe, if this was in the physical world, I mean, they would go and like show you maybe a sofa to your liking. But now like what's of course like so exciting about the future and like what we are able to do, and thanks to all these amazing things like kind of what are now possible with Gen AI and models like Stable Diffusion, we can actually generate like these different experiences on the fly. And of course, like the other big part, what you can see here in the interface is that we have basically for the first time ever in the history of computing, we have this natural language interface to the whole experience. So no more we have that 1970s style database interface where you basically construct the SQL query by pointing and clicking, but you can actually use the most human way of interacting with these services. You can say that, okay, let's try letter. And like then the system actually like hopefully understands what you want to do and generates an appropriate response. And what you can also do is that not only you can use natural language, but you can use the other modalities that are very natural to humans. For instance, I can point at a certain object. I can point at the lamp and say that, well, that looks cool. Maybe I want to buy that lamp. And then I get some information about the lamp. Now, kind of really to motivate this workshop, and of course, like really to motivate, honestly, I mean, the whole conference, if it really needs any motivation at this point, is to really think that, let's say that you believe and like we all like share the excitement that like roughly like we will have experiences like this in a couple of years' time. That of course the question is that somebody needs to build all these things. These things really don't emerge from the void. It will be all of us here building services and innovating new kinds of services like this. And of course, this is also like a great experience for many startups. Like who can really start reimagining these things like even more boldly than like what like maybe larger companies are able to do. Now, from the kind of the engineers, like from the machine learning engineers, data scientists point of view, the interesting question is that like what's actually like happening here behind the scenes. And if we just like quickly go through the functionality here, well, I'm sure that like kind of like you guessed that for instance, like to power a natural language interface, we can use large language models, and of course that's really the exciting part here. But I guess like one thing that's absolutely worth underlining here is that this is not a chat bot. And I think of course like this year you have seen every other company implementing some kind of a ChatGPT style chatbot on their interface. But now, interestingly, as like kind of the years go by and like people get quite used to this chatbot interfaces, the bar will be also raising, and like you will actually like kind of want to get experiences that are more highly tuned to the actual use case at hand. And for instance, in this case, you most definitely you don't want to have a generic chatbot like that you can chat about weather with or like you can ask what's the meaning of life. But basically, what you want to have is that you want to have the most knowledgeable furniture salesperson, and like this thing here like should know everything about like kind of the products that you are selling in the most compelling fashion and nothing else. Actually, it's a liability if this thing starts hallucinating something that's not relevant to the use case at hand. Of course, there are like other things here as well. Like for instance, you can imagine that maybe the user is able to upload a photo of their own living room, and then like we place these objects there, and then there's a bit of a kind of a challenge in computer vision to kind of do this object detection and like a segmentation and recognition here, which increasingly is starting to be quote unquote the solved problem, although it used to be one of the key challenges in computer vision in decades and decades. Now, the interesting detail here about the description is that if you really like read the description that says something about the experience, the essence of Laos's riches, cultural heritage and craftsmanship and so forth, that is actually like all nonsense generated by LLM. And I guess like why that is really interesting is that, again, like if you kind of like a compare and contrast to that to the way how we have been building these services this far, and that like a 1970s style database interface, it used to be so that you had an engineering department building these databases and building the services. And then you have the whole another side of the company, maybe the marketing people, maybe the designers, like maybe the product managers, who then were responsible for actually populating the database with these descriptions and like with all this messaging that like supposedly then like appeals to the other human beings that are the customers. Now, that whole thing is about to turn upside down, and it's about to turn upside down because we can actually automatically generate these things. But of course, again, I mean, we don't want to automatically generate all kind of nonsense, but exactly the same way as before, those descriptions need to highly align with what the company wants to convey and your brand and your style and the voice and the vibe overall. So now like the challenge becomes that actually like, how do we create these LLMs that are actually like highly tuned to the style that we want to convey? Now, like other interesting small details here is that, let's say you are actually like building a business like this. Of course, like you really want to increase sales. I mean, you want to get this like a business off the ground. So marketing is a big part. Marketing is also like getting more sophisticated quickly over time. And for instance, like you may want to have a fancy system that recommends different influencers based on like who you think that the customer is. Maybe the kind of the over 50-year-old get the different influencer, and the kind of the 20 years old get the different one. And of course, like in an experience like this, the actual user interface that is largely automatically generated is a big part of the experience, and like that also like becomes your differentiator. So the kind of a bit of a sad fact here is that I wish this workshop here like was kind of like a private and nobody else knew what we are talking about here. But unfortunately, I can guarantee that there are many other workshops like this going on. Like if not today, at least like kind of a months like kind of around. And it means that there will be like tough competition in who gets to build the best experiences the soonest, which means that like these off-the-shelf things that are kind of like roughly approximately correct might not be enough, but you really want to invest in building something that like really differentiates your offering like from the others, like who are trying to kind of do the same thing. I mean, exactly the same thing what's happening today with the e-commerce. I mean, like everybody is like selling, I don't know, like sneakers online. But there are like actual like material differences between different like buying experiences that you have at different places. And of course, then like when it comes to thinking like what you want to show here, it's again, I mean, it's not random. It very much should be aligned to your business goals. Now, an important fact to keep in mind is that besides all these like sophisticated Gen AI stuff that's going on here, also like increasingly like businesses have all kinds of parts of their business and business processes optimized by machine learning, and oftentimes with traditional machine learning. And of course, like you want to do things like forecast the inventory and like maybe optimize the logistics and like optimize the lifetime value of your customers, and like of course be very smart how you spend your marketing dollars. So all these things are very much coexisting with these LLMs here. So like kind of a very much the world like we are envisioning, and I mean this is like really like not that like a contrarian, is that like we are kind of entering this world like where we have a big mixture of like many different kinds of models coexisting at your company. So like let's say here like we have 10 different machine learning and AI systems that somebody needs to build, and of course for all of you here in this workshop, like, and I believe like many of you are probably like builders of different kinds. Maybe you are product managers, maybe you are data scientists, maybe you are software engineers. And if you look at any of these things, I mean, you should be kind of shaking your head. But oh my gosh, like each one of these things is actually almost like a research project of their own. These are all unsolved problems. And now you imagine that like you actually have to deliver these systems. Really a key challenge is that like kind of, well, how can we do it in any kind of like reasonable time frame with any kind of reasonable like a budget and then like a headcount allocation. And of course, one big part of the solution here is that like definitely you don't want to build every single project here from scratch. Like you don't want to kind of like start setting up AWS accounts for each project like over and over again. But rather, at least like you would hope that you would have some kind of a baseline, some kind of maybe a platform infrastructure that would be available to all of these projects so that they can get off the ground, they can start prototyping, they can start testing, experimenting different ideas as fast as possible. And now this is of course something that like we have been like doing with open source Metaflow and like back at Netflix and now at Outerbounds like for a long time, really thinking that like what are the common elements here. And I can just like quickly go through these things because we will like dig much deeper into these questions during the workshop here. But one thing that's really kind of easy to agree about that all of these projects need data. Now, I mean, of course, the data modalities are very different. For instance, like what you need in the image generation is like maybe large amount of unstructured data, whereas like the inventory forecast might be few tables inside Snowflake, and the query LLM is, of course, maybe some kind of like the instruction tuning data set and so forth, but like a data nonetheless, you want to access. Now, another huge part, and this is an increasingly important part of the whole stack, is the question of compute. Now, building all these models like requires compute power. So, of course, like a traditional machine learning model, let's say like you do some like a basic regression model or time series forecasting model. I mean, it's a very modest the amount of compute power that you need compared to LLMs, say, or like not to mention like maybe some kind of image models or video models. But at the same time, you may want to do some kind of hyperparameter tuning. So, I mean, the compute requirements might be more than what you can do on your laptop. And of course, like in these other cases with the Gen AI, there's a big question that even the hardware that we use to kind of do the compute is getting more heterogeneous. So it used to be so like for the past 10 years that like we could just like launch a bunch of boxes in AWS and like we get a bunch of CPUs and we can train models on those CPUs. But now suddenly we are in this situation that, well, first, I mean, we do need to get some kind of hardware accelerator, GPUs. And then also like there are so many kinds, like Amazon today, AWS has like 35 kinds of AWS of GPUs available. And this kind of a complexity is only about to explode next year, like with the different accelerators coming from AWS itself. And like Google has TPUs and AMD is releasing new things. So the compute question is becoming ever more complex. Now, like one of the key ideas of this workshop is to really emphasize the fact that like we are not only here to build models, we are really to build systems. And like when we are putting the kind of systems hat on, we realize that we get this machine with many moving parts that need to be orchestrated somehow, making sure that everything stays up and running, runs at the right time, stays highly available and so forth. So that's a big piece. Also, another big realization is that we never get these things right from the get-go. And in none of these cases, it is so that you just go ahead and spend 1 month implementing the LLM, or like you spend another month implementing, let's say, the kind of the recommendation system model, and then like kind of you deploy it and you never think about it again. But actually, like it is very much so that the kind of the project only starts like when you deploy it for the first time. Now, if you think about, as an example, a system like Netflix's recommendations, that has been worked on by a team of people for more than 10 years, day and night, 24/7. That system never goes down. There has been always a team like working on it, responsible for it, and that project never ends. And it means that, like, of course, in order to be able to make any kind of continuous progress, like you want to keep track of like everything that's going on, like the data changing, the code changing, the models changing. And with that hand in hand goes the question that how do you deploy these things? I mean, you can imagine that the way how you have to do the real-time inference, like for these images, is very different than, let's say, what's the batch predictions for the inventory forecast. So many different patterns there. And then, like at the top of the stack, there's the question that now, as of today, let's say you may use Stable Diffusion XL for the image generation, or maybe use Llama 2 for the query LLMs. But I can guarantee that, of course, it's just a matter of like maybe a month or two, and like we get the Llama 3, we get the Llama 4, Llama 5, or like whatever, like the next versions of the Stable Diffusion model or DALL-E or whatever it is. So the models move quickly. So now, just like a quickly motivate, like why, let's say, like in this workshop, and like we are using Metaflow, and like why hundreds of companies are using Metaflow for use cases like this, is that now, like overall, like when you take the mindset that like you want to build, like you want to build your business around these machine learning AI models. I mean, not only one. If you build only one model, and if your plan is ever to only build one model, I mean, honestly, I mean, there are many options available, and it doesn't make a huge difference. But for any one of you who are planning to maybe iterate on a model over time, or like build more models, so like optimize business on multiple fronts, like kind of apply AI in different domains, you really should be thinking about the full stack of components you need in your infrastructure. And you need to really have the systems mindset that I'm not here only to build like one large language model, but I'm here to build a system, an experience, a product that uses a large language model as a component. And then when you take that mindset, of course, then the question becomes that, okay, what are all the moving parts around the large language model? And then also, like, how do I embed the large language model in my project? And I guess this is another way of saying the same thing, that here's like, for instance, like another hypothetical architecture, like what the kind of world is going to look like. And here, for instance, you have a one workflow that, let's say, uses some like open source foundation model, maybe does some like a fine tuning, and then like maybe uses that fine tuned model to produce some embeddings. And now those embeddings in turn are then used by a recommendation system. And this recommendation system might be like using kind of the state of the art, like Rex's models, just like using these LLM embeddings as a component to ingest unstructured data. And like while this side of the house is running, then also like maybe we are using some API to generate images and so forth. So like what's kind of like emerging here is that like we get this increasingly complex machine of multiple moving parts of many different models that are all interactive. And like how a system like Metaflow, for those of you who might not be familiar like with the open source Metaflow, how it helps is that it just like addresses like all these different layers of the stack. So helping you to access data, helping you to access this heterogeneous, increasingly complex compute landscape, helping you to kind of build these systems and orchestrate them robustly, while keeping track of all the versions of code data and models automatically and everything that goes on inside these pipelines. And then like supporting different deployment patterns, like recognizing that there isn't like one size fits all. There isn't like that, oh, everything ends up being a microservice like this. But sometimes you need streaming inference. Sometimes you need real-time inference. Sometimes you need batch inference. And like you better be able to support all those use cases. And of course, like as a kind of a cherry on cake, recognize the fact that like we are not going to use like TensorFlow for anything. We are probably not even going to use PyTorch for everything. But I mean, like we want to use the best model for each job and like the best framework for each job. And also knowing that all these frameworks like evolve fast over time. So this is kind of hopefully like motivating a bit like what we are going to talk about today. So and also like another thing before we really get like to the hands-on part, I just want to mention that there's kind of like two sides to this stack. One side of the stack is that like what is the user interface that the developer sees, kind of the Python API, and that's of course a big part of like Metaflow. And if you wonder that, okay, why Metaflow in contrast to any other tool that exists out there, I mean, ask yourself that like what is the developer experience of the tool that I'm using today, and then compare that to Metaflow, and that's kind of the thing that we really obsess about. But then the other side of the coin is the question of infrastructure. And in order to make any of these layers work, you need to integrate with existing systems. So of course, it would be nonsensical to kind of reinvent every wheel here. So we want to integrate with your existing data warehouses, Snowflakes, these Databricks, maybe S3-based data lakes. And we want to kind of run compute on things like Kubernetes, maybe AWS Batch. And Metaflow helps you like with the orchestration, because that's actually like one part that's really critical in the middle. But then like when you are deploying these models, we also like integrate, let's say like if your company has legacy Airflow pipelines and your data engineers insist that they want to keep using Airflow, I mean, that shouldn't be a blocker. I mean, you should be able to kind of use Airflow alongside, and even so that like you're able to export the Metaflow flows to your Airflow system. And the same thing on the modeling side, that of course, like we don't want to reinvent any of these machine learning libraries. And on top of this, there are, of course, like in an actual like production enterprise environment, all kinds of additional questions that, okay, we need to do all this in a manner that like respects the data governance. Of course, it needs to be operationally like highly available, like needs to be observable. I mean, and of course, like we also have to think about like how do we actually like develop this system? I mean, do you do it on your laptop or do you do it in a cloud workstation? So if you are interested in ever getting help like to this like a full picture here, like you can go to outerbounds.com. I mean, this is what we do for a living. But the whole point here today is that actually like you don't have to do anything like kind of outside what's available in open source. Now, one thing that like we wanted to do today, just to make it easier for you to get started, is that instead of you having to deploy Kubernetes and like kind of set up an AWS account and like set up things like Argo workflows, we have actually made this full stack available in the browser. So actually, like now you can start heading to outerbounds.com/sandbox, which is basically a VS Code IDE inside the browser. But I mean, the key part is that it comes with the private stack like this that is provisioned for you on the fly. So you kind of get to experience this systems building aspect, like hands-on, like without having to actually like go through the deployment process by yourself. Now, just like 1 minute before like we actually get to the hands-on part, I wanted to just like give a quick overview of like what we are going to cover now, like kind of for the rest of the workshop. So as you remember, the title of the workshop, and hopefully the reason why you are all here is LLMs in practice. So we will be really like diving deep into that question that like, if you want to start building those like new kinds of experiences that what I motivated before, like how can you actually concretely go about doing it today? And like we start with the most obvious answer that like maybe many of you have done already, which is that like you hit, let's say, OpenAI APIs and like cover that, okay, what are the pros and cons of that? Then we touched the question that let's say that like if you didn't want to hit one of these like existing commercial APIs, but I mean you wanted to have more flexibility with OSS models, like open source foundation models, what would it mean? And then after that, like we dive into this question of the kind of approach of retrieval augmented generation or RAG, and like why on earth like would you care, and like what it means, and like what are the implications, and how it touches these different parts of the stack. And we kind of do like a very gentle hands-on approach, like showing how RAG works, so you really understand what's going on. Like we don't want to hide the details. We want to give you the kind of the fishing rod and not just the fish. So let's talk about the fishing rod first. But then after that, we definitely want to go like kind of like 2 steps deeper and like give you the whole like a fishing boat, so that you can actually like operationalize the whole show, and you can actually like put that RAG in production. And this really goes back to the idea of taking the systems point of view. Like we are not only like showcasing these theoretical approaches, but really starting to show how you can actually start building your own businesses, your own ideas, your own products around these concepts. And then time permitting, hopefully we have time in the end to really touch the question of fine tuning a custom LLM. And like, if you were like crazy enough, like you could even like kind of build your own foundation models. I mean, it's totally doable. Definitely a bit more expensive. There are also cheaper approaches, but I mean, of course, the compute becomes really a key question there. So we can touch that one as well. So, anyways, I hope you are still following, and definitely now you can actually like get your hands dirty by heading to outerbounds.com/sandbox. And I think that this is a good point for me to kind of hand it over to Eddie, and like Eddie can start showing how things work on the sandbox side.
Awesome. Great lead in, Ville. Thank you. Go ahead and screen share. Also, while I'm doing this, Ville, there was a good question about the different cloud providers in the chat. Maybe you'd want to throw some extra ideas there. Yeah,
totally. So while Eddie is getting going with that, I can try to find the chat here.
So the sandbox link that Ville mentioned, you can also find from the Git repository that was linked in the chat for this session. And then there's some basic instructions to kind of set up the workspace that we're going to be using, which the workspace is literally this GitHub repository. So I've already created my sandbox at outerbounds.com/sandbox. But you can just click this link, hit Explore Sandbox, get started for free. These both go to the same place, and you should get your sandbox relatively quickly. Okay, and then the second step that we're going to do is we're going to clone this repository. So I have not done this in my sandbox yet, so y'all can follow along with me. I'll kind of show you what this looks like in Slack. So I'll go ahead and copy and paste this instruction. And now we see that I have the generative AI cloned in my repository. And then once you've cloned the repository successfully, you can just click this link and it'll open up directly into the workspace that we want, which will have this generative AI summit file in it. So while this is opening up on my end, I'll kind of click around to the beginning. Looks like there's some state saved on my sandbox.
So Eddie, I don't think we can see like what you're sharing. We can see the sandbox now.
You can see the sandbox? Do you see the sandbox?
We can see the sandbox.
Okay, good.
Like what was the other? Yeah, I think there was something else that I think it disabled the sharing.
Okay. I'll just stop and reshare. Are you seeing like again on the sandbox today?
Yeah, we can see the sandbox now.
Okay, great. So when you open this up, you'll want to start off by running this setup script. This is basically just to clear some space. Like we're actually going to be downloading some pretty sizable models because, I mean, not GPT scale, but they're going to be 500 some odd million parameter models into the sandbox instance. And this is not the most powerful computer you can ever imagine. course, like Outerbounds is providing this infrastructure for free, so we're not going to give like the biggest GPU on the market available to everyone. But point is this setup script is going to create some space in your sandbox because there's a bunch of other content that exists that you can find on the sandbox by default. And we just want to make some room so we can run this. So I'll go ahead and run the script. You can just run the Jupyter cell directly as is. And this will just take a minute or two to run. While that's happening, you can click down to these other links. You can explore what's going on. And this will keep running. So as long as this keeps running, you're good. And
so by the way, can you increase the font size a bit?
Yeah, for sure. Oops. How does that look?
Yeah, better. Thank you.
Yep. Cool. So again, as this is running, I'll just scroll through the sections and just kind of connect to what Ville was saying earlier about what these hands-on sessions are actually going to be doing. So we'll start off just by generic kind of inference with LLMs. We'll play around with ChatGPT a little bit. We'll see some other APIs like from Cohere and an Israeli company called A21 Labs. We'll see how these are all kind of similar APIs and how we get somewhat similar responses in our Python code as we would if we just kind of went over to the ChatGPT interface and just started naively kind of typing our queries in. Then later in this first notebook, we'll start to kind of mimic that same experience using a Hugging Face model off the shelf. Again, we're not using the most powerful Llama model or something like this. We're just kind of showing that there's many different versions of these open source models that you can use to somewhat recreate aspects of the experience that you would get with these OpenAI or another provider's commercial API. Once we complete that, we'll move into a basic kind of introduction to prompt engineering, which is kind of just modifying how we talk to these models to get them to do what we want. So not really changing the model itself, no fine tuning or anything like this, no using our own data, but just kind of changing how we communicate with these models.
So maybe, by the way,
yeah, go ahead.
Before you move on, there was a question that like, how do I get the repo into the sandbox? So can you show that the beginning part again? So
yeah, exactly. So in the second step here in the GitHub repository, after you've already kind of opened up your sandbox, you'll be in a page where it says tutorials. So you'll have some kind of identifier here that says tutorials. And the end thing that you really want is to get this generative AI summit identifier. And the way that you can do that is you can copy and paste this command for this git clone, which is just the name of this repository. And then if you click this link after you've done that, and after the clone was successful, then you'll open up the sandbox in a new browser tab, and it'll just open directly into that workspace that I'm showing you right now. So I'll keep kind of chattering here for a couple of minutes just to let people who want to follow along get their sandbox set up. But also, as you do that, remember that you want to run this setup script. It takes, on my computer, it took a minute, 20 seconds, so not terribly long, but just kind of get that going so you can start following along with me right when you do this sandbox ready. We start the actual running of code part of this. So continuing with the story, then as Ville was mentioning earlier, there's kind of this whole notion of retrieval augmented generation that's become quite trendy of late. And we'll go through just kind of the basic workflow, like kind of unrolling what a RAG iteration will look like. And then following that, we'll go into using Metaflow in the sandbox to actually deploy workflows on the cloud that are going to be running in the background. So it's like not running on this computer itself, but it's going to be running on other workflows, which is kind of deploying workflows with Metaflow. And we're going to see kind of how to link different workflows together and get into this more systems mindset of how we can take the code that's unrolled in this notebook and package it up into production-ready workflows orchestrated by Metaflow. Cool. Ville, could you let me know, do you think it's a good time to get started, or is there more activity in the
chat? Definitely. Yeah, I mean, like, put a note in chat, like, if you are not able to see what Eddie is showing here, but otherwise, like, we can just get going and yeah, okay. Like, just note in chat if you have any trouble.
Cool. So first things first, we're going to talk about that deployment layer, and this is really just like, I don't really care about owning the model supply chain. I just want to use the OpenAI API. I want to use the Cohere API, use Cloud from Anthropic, and just get something that's kind of in my Python environment that's mimicking what I might see when I go to ChatGPT. So to get started, we're going to install these Python packages. We have OpenAI, Cohere, and A21. So you can run the pip install commands just directly in the notebook if you'd like. You can also copy and paste them and run them down on the terminal here. And what I'm actually going to do when I'm running the code is just do it down in the terminal, so we get a little bit more informative print statements, kind of a little easier to visualize things as we go in between notebooks as well. I'm going to go ahead and paste from the notebook these import statements, which we can see.
If people want to follow along, do they have to do it in a terminal, or like can you just execute the cells?
Yeah, you should be able to execute the cells. That should be no issue. Sometimes the notebook interface, I've noticed, just kind of hides some of the relevant print statements when we're using these APIs in the transformers package. So just to be more verbose, I kind of prefer the terminal. But yeah, you should be able to do whatever you want and use it like a notebook as normal. Also, pro sandbox tip: if you're interested, you can make a new link here, and if you just take everything after the /dev off, you can also type Jupyter, and then it'll open up a classic Jupyter interface if you prefer that over the VS Code that we're looking at right now. There's already a kernel running, and you can do everything there as well. So kind of the world is your oyster here. Like you can use the sandbox however you want. It's like a full IDE environment for you to do your thing. Cool. Okay, so I've imported these libraries, including the main players of this notebook, which we have the OpenAI, the Cohere, and the AI21, excuse me. Now, you're going to want to get an API key. So if you haven't done this before, these links will take you to the API key kind of sign-up flow for each respective company. So I'm going to use OpenAI. So if you click here, we'll see is that it opens up directly into my specific account.
I don't think we can see the other tab. I think we can only see the sandbox screens.
Got you. Oh, so I probably missed that whole Jupyter riff that I did then.
Yeah. Yeah.
Okay.
I think if you share your entire screen, I think then you should be able to see it.
Oh, right. I can do the full screen. Much better. Okay, cool. So now if I click over here and kind of click around, you can see them all.
Yeah.
Okay, yeah. Great. So what I was showing earlier, just if you want, is after this .dev thing, if you want to just type Jupyter, you can go into this classic interface if you don't like VS Code for whatever reason. Now, the thing I was showing with the API keys is that you can click this link and it'll open up to this page if you already have an OpenAI account. If not, it'll kind of prompt you for a sign-up flow. You can also always find this just Googling API key, OpenAI, or something. And then kind of go through the normal flow. Let's click sign up here. It'll take you into a screen like this, and just it should take less than a minute or so. Now I'm going to go back and copy and paste from here. Each framework also, by the way, is like kind of part of what we're trying to show here is that each framework is very similar. So let's just create a new AI new key. Okay. So now that I have this new key, go ahead and paste it into my Python code. Of course, like in a real production setting, like you're going to want to use environment variables. You're going to want to like maybe put this in a secret. Things that like, of course, as we like move to production with Metaflow, there's features built into the framework to do this. But for now, this is fine. And of course, I'm going to delete this key after the presentation. Okay, so now that we've done that, we're ready to kind of get going with the OpenAI API in our code. So to give you kind of a reference point, let's actually go to the ChatGPT interface itself. I'll use the GPT 3.5, and we can just type in some sample prompt. I'll generate that affecting the infrastructure and machine learning developers need to access. We can get the normal options. We see it doing its streaming. Just response kind of coming in, gives this like typical like sort of listicle format, but pretty good response, I'd say. In this case, is like I've done this prompt many times, so I kind of know what it's going to look like. But it focuses on the important things like increased compute, scalability challenges, data storage and management, a lot of the stuff that Ville was talking about earlier. So now as like the basic hello world here, let's copy and paste this prompt into our terminal. And using the OpenAI framework, we'll set the OpenAI key. Now we'll use the same exact model, this GPT 3.5 Turbo. If you pay for the Pro plan on the ChatGPT, then you can start to get, excuse me, the OpenAI API. You can use GPT-4. But just to keep this accessible to everybody, we're going to use GPT 3.5. Now what we see here happening is kind of the analog of what happened in the actual ChatGPT browser, where it started streaming the response. And of course, right now it's not streaming anything. This is all just kind of happening in one API request. But this openai.chatCompletion.create, we're actually sending the same exact prompts over to the API. And then we see that it completes in roughly the same time that it took for the interface itself to kind of stream the response into my browser. So now I'll just do a bit of post-processing on the object that the API returned, and then we can print the GPT response. And we see something very similar. So it's responding kind of in that same format, the generative AI techniques, such as GANs, autoencoders, blah, 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 and then kind of this list of different things that are relevant based on the prompt, which again was just kind of a generic question about how Gen AI is changing machine learning. Okay, cool. So if you're curious, you can play around with a bunch of different frameworks here. Like we have the Cohere one. You'll notice that the APIs are very similar. So we have like chatCompletion.create, Cohere.generate. We have AI21, completion.execute. These are very similar all around. So I don't want to spend too much time here, but like have fun playing around. These things are kind of good at different things is what we're going to talk about now in the next section here.
So Eddie, there's a question here that someone is getting an error. Output exceeds the size limit. Open the full output data in the text editors.
Output exceeds the size.
I think maybe when you execute the notebook cell, it might be that the output is too long.
That's on the cell here of the OpenAI API. It shouldn't be printing anything here right now. So I'm not sure where that would be coming from.
Yeah,
I
guess it might be the notebook.
Yeah, maybe it's the notebook kernel in this case. I suppose, yeah, then to counter what I said earlier, maybe it is a strong suggestion to try and use the terminal if the notebook is giving you issues.
Yeah, but it should only affect like the ones maybe that produce a lot of output. So I think it should work behind the scenes. So I think you should be able to follow along anyways.
Yeah, please let us know though. Keep letting us know if you have any issues, because of course we want to actually package this up after the workshop and make it much easier to use going forward. Another thing that I have seen before in the sandbox, by the way, is that sometimes the Python, the notebook kernels in the VS Code kind of have a strange interaction with VS Code. So that's another reason, maybe if you want to try the Jupyter interface, if you want to stick in the notebook, you can go there and see if that resolves any of these issues. So, okay, main point there is that we can kind of get what we saw over in the interface here on ChatGPT inside of our Python environment and then start to use that in our own programs. Now, like, obviously, that's like the most basic use case for OpenAI. And there's a lot of different APIs that we might want. So Ville had the picture earlier of like kind of the query LLM. We had the summarizing LLM. We had object detection. There's tons of different APIs in this realm that we might want to use, both in the generative AI landscape and the classical machine learning landscape, and sort of mixing them together. So we put together a little table here, which is just us perusing the documentation of each of these tools, and then kind of looking at what endpoints the API had available. So this is, of course, like subject to change. Like this will totally be out of date in 1 month. These APIs are changing super fast. But this will just give you some kind of sense of the coverage that each of these different tools has for different things that you might want to do with them, depending on your application use cases. So if people have anything interesting that you think isn't covered here, if there's something that you definitely want to hear Ville and I talk about a little bit, feel free to let us know if any of these things are the most interesting to you in the chat. But I'll kind of keep moving now, because there's like below this, you'll find some opinions that we've gathered based on this and our sort of initial R&D into using these different tools. There's kind of a decision tree here, I suppose, of different ways that you might want to think about using certain endpoints for certain use cases. I think it's like pretty clear to most people in the community that the best chat model is GPT-4 right now. Even amongst the commercial APIs, it's pretty head and shoulders the best one. Multimodal is a topic that's been really, really hot lately. And this is another place where OpenAI's APIs really shine. The DALL-E 3 announcement within the last month is super impressive for this kind of vision meets text world. And then they also have an audio API, which is powered by the Whisper model, which is very useful if you, say, want to transcribe videos or podcasts or something like this. If you're interested in content moderation, Cohere and OpenAI both have specific APIs to do this. Again, not that the other tools couldn't do this, but they have direct APIs. Like in OpenAI's case, it's called moderations, where you can sort of start to get things like different categories of text, being able to classify them as like hate speech or something that you would definitely not want to be surfacing through your product experience just by virtue of like you use somebody else's API in your product. So this can be super important as your use cases get more and more serious, and especially if they're user facing. In terms of multilingual models, like something we'll see in the prompt engineering section of the workshop is that you can do this with the raw OpenAI API itself. But Cohere has a dedicated multilingual embeddings feature, which is quite interesting to play around with if like machine translation is a use case that's important to you. And then the final thing here that we noticed is that A21 has a very interesting API for like basically grammar. So it's integrated with this tool called WordTune that behaves very similar to Grammarly. If you're familiar with kind of having Grammarly look into your Google Docs or whatever you use in your browser, and it kind of gives you this ability to have part of these API responses include things like correction type of a word repetition or a spelling mistake, things that can kind of help you sort of have editors in your product experiences as the users are writing. Cool. Ville, is there anything you'd want to say on kind of the collection of these APIs, or should we just keep moving into the open source?
Yeah, let's keep moving. We have a lot to cover.
Cool, let's do it. Okay, so now I'll try to go as quick as possible here in the bottom section of this notebook. This is basically like hello world space. So I assume a lot of people on this call have done this many times over. But the idea here is basically that there's very simple APIs in the open source community too, where we don't just have to call somebody else's API. We can actually get the model on our device, in this case on the sandbox instance that Outerbounds just created for you. And then we can do stuff like grab the T5 model, which is kind of a state-of-the-art instruction tune model from Google. We can sort of start to do stuff like print it out and see this is like the actual
and maybe Eddie,
structure. Yeah.
Like actually, like before we dig deeper, in case that like maybe not everybody has been playing with the open source model. So there was the one slide where we kind of motivate the open source model. So I mean, we can quickly like just before we dig into details, like motivate that. Okay, I mean, why on earth like would you take that route in the first place? So
yeah, definitely. Could you remind me? Is it above the?
Yeah, you know, if you keep going down, yeah, there's after. Yeah, there we go. So if you can like yeah, if you want to put full screen, so maybe like easier to see. So anyway, so just like I know that like we are going at the there's something covering no, don't think it is full screen. Okay,
sorry about that.
Yeah,
how do I even do this?
If you click slideshow, does it work?
Is it still covering?
It's still covering. Anyways.
Well, it's big enough if it's the...
Yeah, no, it works. That's fine. That works.
Google Slides issues.
Right. Yep. So, so what Eddie was showing before is like how easy it is to hit these commercial APIs like OpenAI and all the others. And now, as actually like some of you already noted on chat, like these are indeed commercial APIs, which means that like I think Eddie might have had even some like a commercial plan, so he doesn't maybe have the same rate limits and so forth. So there are of course all those issues, and many other issues like why you might actually like want to start like looking into the open source foundation models instead of using these commercial APIs. And really like one thing that's really obvious is that of course it takes more effort as of today, but like especially like thinking the long term, like the years to come. And like imagine that like everybody wants to start embedding these LLMs in their products, and the competition is getting tougher. Like all these questions listed, for instance, on this slide become quite relevant. So like for instance, like the big one, like let's say if you happen to work with privacy sensitive data, is the question that are you leaking data to these outside services? Then the other one is that as these models move on, as all of these vendors actually update their models, you have absolutely no control over like kind of what happens behind the scenes. So like imagine having that SOFA experience, and like one day, let's say you are using an OpenAI API, and OpenAI decides to change their model. And now suddenly, like your e-commerce store basically starts misbehaving because of the OpenAI changing their behavior. So that would be quite an annoying thing. Now, like for those of you who might be working on some like really sensitive data sets, let's say in healthcare, of course, there are even legal concerns that like what kind of data can we even use to train these models, and then like do the pre-training. And now an interesting question is that, which is like very much like a quickly evolving story, is that it is a bit unclear that like what is the cost efficiency of using these external services versus doing your own. Depending on your use cases, depending on your usage patterns, like hosting your own models actually like might be more cost efficient than like using this open source, or like using the proprietary APIs, or it might be the other way around. But really the kind of the last 2 points here are the most important ones, which is that the problem is that like if you are only relying on these external APIs, you are basically like playing at the very same playing field as like all the other companies sitting the very same APIs. And now, of course, like going forward, like really the big question is that like how do you innovate and how do you build unique differentiated products? And that's why like some companies like who really consider this to be an important part of their offering, like might want to kind of take the ownership and like actually start like building your own intellectual property, start like building your own like a secret sauce on top of this. So Eddie, if you just like quickly show the next slide before we move on. Of course, the kind of the other like other side of the coin is that, okay, why you wouldn't want to do this is that obviously like it requires more effort. Also, like there's no question, as Eddie pointed out, that something like a GPT-4 is like just like looking at the default responses. If you don't do anything, it's really like quite like above like anything else as of today. And the point is that like depending again on your use cases and like the usage patterns, like the operational cost may be higher than like just like hitting these APIs every now and then. But like with this motivation, and especially like keeping in mind that like for those of you who consider LLMs to be a really important part of your product, you definitely like should be now like kind of looking into these open source models. And like it's actually like surprisingly not hard given like how much magic there is going on like under the hood. So Eddie, like back to you.
Awesome, thank you. Very useful interjection there, appreciate it. And feel free to stop me, of course, at any point. Okay, so back to like now, what's the basic way that we can use Hugging Face, which I think is most people would agree is kind of the state of the art in terms of accessing these open source models. Like Hugging Face has this thing called the Hub, which is essentially like the most standard place where people are shopping for different models, like this T5 thing or the Llama model that Meta is released. There's many hundreds, thousands of models at this point that are being uploaded every single day there. So they have these really simple APIs where you can kind of pull a model in. You don't really need to know very much about the PyTorch code that's underneath the model. You just call this auto model.from pre-trained. We're loading this onto our device. And then I'm not going to really do anything interesting with this model. I just kind of wanted to point out that unlike GPT-4, where it's like, I mean, maybe you can try and read the tea leaves of the paper that OpenAI put out and understand what the model actually is from an architectural point of view. You can just print it to your computer right here, and you can see exactly what this T5 model is, where this is just showing you like these are the actual layers of the neural network in the PyTorch code, essentially. So there's some interesting tools here if you guys want to take a look. I won't take too much time here. Like especially this BurtViz thing is very cool. If you use Hugging Face, it kind of like shows you how the transformer architecture is changing as you like have a sample sentence. But just for time's sake, we'll keep moving fast here. Now there's a bunch of different things that you can do in Hugging Face. Like so again, back to this idea of like you don't just have an LLM chatbot. It is kind of like the current state, but as people are moving forward and thinking about more interesting application designs for how to use generative AI, we have a ton of different tasks that we might want to solve for, including more traditional recommendation systems, just kind of producing the embeddings for things like this, including vision tasks like object detection. So Hugging Face has this nice kind of task, I guess, abstraction, and they have a whole bunch of different kinds of tasks where you can shop for different models here. Say you're just interested in question answering. You can kind of see like a whole page teaching you how to use this stuff. So definitely worth checking out if you're kind of in the mindset of like almost like a product manager or kind of a product designer trying to think about what's possible. This level of abstraction of thinking about the tasks is really useful. So now as an example here, one thing that we can do is just kind of basic text classification. So above we saw text generation, which we'll see in a second. But before we go to kind of like matching what we saw with the OpenAI API above, we can look at something like text classification for sentiment analysis. So we have a couple sample sentences here, like I'm feeling inspired, what a time to be alive, and say that we wanted to do something a little bit richer than kind of maybe the hello world that you might see in an NLP course where we're classifying something as like positive or negative. And that's kind of all we get. It's just this binary classification. One of the really awesome things about Hugging Face is how easy it's made it over the last couple of years to have just a few lines of code where we're just finding a model off the Hugging Face hub, creating this pipeline, which again is just one line of code, a text classification pipeline, set our sample data, and then we just put these sentences directly into the pipeline, and we should get a printout like this, where we kind of are getting this much richer sense of the sentiment analysis problem, where we, instead of just having a positive, negative sentiment, we have labels like excitement, admiration, curiosity, neutral. So there's maybe a bunch of different ways that product designers more creative than I am could think of for how to use something like this in their actual products and apps. Now, connecting to what we saw above, there's a different kind of task that we can do, which is text generation. And this is the thing that's going to really closely match sort of that basic chatbot loop that we saw above with the OpenAI API. So we'll use this model called Bloom. Hugging Face had a project that they sponsored, and a lot of the R&D was done by Hugging Face researchers called Big Science. And part of the Big Science project was training these LLMs in a completely open source way. And one of the models' name was Bloom. And in this case, we're going to use one of the smallest versions of Bloom. The big ones go all the way up to like near GPT-4 scale. But this one is just small enough to fit on the sandbox, and we can do an inference in a reasonable amount of time on the CPU that's attached to your sandbox.
So, Eddie,
yeah.
By the way, like before you move on, there's a question, like a couple of questions. The first question was that like, does score mean probability here? I guess that like refers to the previous response that you were showing.
Yeah, that's a good question. Close, and yeah, like it's not exactly how I describe it, but that's close enough to what it's talking about. It's kind of like a 0 to 1 sort of likelihood in this case. But something to realize about Hugging Face too is kind of like you can always go to these models, and if you have questions like this, we can type in the model in the Hugging Face hub, and we can just go find this information for ourselves. It's pretty useful to be able to know. So we have this Roberto based emotions. And we can go read all about like what the data set is, like how the model was created, and kind of get a full sense of what we are looking for here, and even see like the actual files that we're downloading as we do these higher level APIs in our Python code.
And Eddie, another question here was that did you import the model up to a certain layer, like in transfer learning, or like was it the entire model?
Great question. That's going to be case by case specific. But yeah, in this case, we're not even really doing any learning. Like this is a pure inference case. So we're just taking the whole model architecture, downloading it to the computer, and then we're not doing any kind of learning per se. We're just using it to produce inferences, what's already been trained. As Ville mentioned, time permitting, we might get to fine tuning later, where we actually are doing something like pulling some of the parameters into our computer, modifying only a tiny subset of the parameters, things like this. But that might be beyond scope unless we have time at the very end for that.
Yeah, but I guess then Eddie, like I guess like you took the full model and then you use the full model for inference, right? Like in this Bloom case.
Yeah, exactly. So let's continue with the Bloom case where we've got this generator now, and we'll do a prompt, which this is kind of like, this is essentially what ChatGPT is doing behind the scenes. It's like a little bit better interface because you're not just typing like half of a question like this or half of a statement like this. But these autoregressive, you might have heard that term, it's like the data science term for what these language models are doing. These autoregressive models are just kind of continuing based on what they've seen in the past. So what we want Bloom to do here is just complete this sentence, essentially. And that's basically how all of these LLMs are working behind the scenes. So we'll see here that this is kind of the latency of a model that's probably 1,000 times smaller than GPT-4, something like that order of magnitude. And this is actually running, the model itself is running on the computer, which is like a small instance in the cloud, like probably not as powerful as your laptop kind of computer. But you can see that it's like reasonably fast. And then if we print the response, make this a little bigger, it's easier to read. If we print the response, we'll see the Generative AI World Summit is and then it finishes with global conference that brings together the best in AI, machine learning, and artificial intelligence. So we can see that the language is not terrible, but there's also kind of this obvious deficiency relative to something like OpenAI's API, where there's no kind of intelligence that appears to be emerging from this, in the sense that like it uses AI and artificial intelligence in the same list, as if those are different concepts or something like this. But nonetheless, like we have a model that maybe we could take this and fine tune it. And also like this is not doing justice to the Bloom project, where like the big model actually is really quite good. Yeah, so that's kind of like the basic loop that we have for doing inference. And I think that's mostly it for this first section. And then in the next sections, we'll kind of move into like, how do we go beyond this? Like without doing anything super fancy and kind of like transfer learning or fine tuning, like how can we just change how we talk to these models, both in the ChatGPT interface itself and in our code, so that we can programmatically start to kind of make these iterations better and maybe make stuff like this where it kind of doesn't really even understand that AI is artificial intelligence, behave in a more appropriate way for a real use case. Before I move in that direction, Ville, did you want to bounce back to the slides, or do you have any comments so far?
Yeah, well, I mean, maybe if you can like just like show the next slide there, just to motivate, like again, I mean, like what has been happening here. So like we tried the open source models and like we got some responses, like Eddie was showing, they kind of make sense, like not not terribly bad. And yeah, if you, let's see, like if you show the prompt engineering, I guess there's some lag, yeah.
Okay.
Yeah, that works. Yep.
Okay, I'll just do a slide checker.
Yep. Yeah, but like this is kind of the big picture, like kind of the way how we think about these things, because now for many actual applications, really the kind of the big question is that like if you are not happy with the results, what can I do? So now like you can do exactly the steps that Eddie was showing, let's say with the open source models, and you get some responses. But I mean, maybe you deem that the responses are not good enough, like for your use cases. And pretty much like everything else that like we will be talking in this workshop, like for the next like 45 minutes or so, is about increasing the relevance of the responses. And there are different ways how we can achieve that. And now the kind of the next kind of like a simple technique that we are showing, of course, this may be really familiar to many of you already, is this idea that like we can just embed more information in the prompt. So like, for instance, in this image at the very bottom, like you have this like a blob, which, and like the darker these blobs are, the kind of the more like relevant they are like for our use case. So we can just like embed a lot of context in the prompt. And then we can still use this like totally generic model like Bloom that basically knows nothing about our specific use case, but we just hope that like it understands the prompt well enough to then like produce some response that is like hopefully like relevant enough for like what we want to achieve. And then like after the prompt engineering, like we even like dive deeper into other techniques that like can even increase the relevance further. So I guess that's all I wanted to say.
Awesome. Cool. Okay, so the next section is all about this prompt engineering topic. It's getting a little cluttered, so I'm just going to zoom out a bit. But please holler in the chat, or Ville, just let me know if I should increase again. So yeah, just the picture that Ville was just showing, we kind of see it here, where we previously were kind of using this generic LLM over in column 1 here. And now we're going to kind of move into this second column where we are increasing the relevance basically by increasing the relevance of our prompt, just including more data in the prompt that's relevant to how we want the model to behave. So before we do this programmatically, kind of continue with the sort of like this journey of doing it in our Python code, I want to show you how to do this just in ChatGPT by itself. So we've written this kind of like fun, silly thing called a system message. And this idea is basically, it's like you're not really changing what you type as a user into ChatGPT, but you are changing kind of the guide that you tell ChatGPT about how to respond. So there's actually documentation and like many repositories online of like examples that people have collected for how to do this effectively. But I'm going to go ahead and just copy and paste this and just show you instead of continue talking about it, where you can go into your ChatGPT interface. And in the bottom left, you have this thing called custom instructions. And here it has a couple of questions. And these are the things that I'm referring to as system messages, which are basically like background guides that you're giving to ChatGPT about how you want it to respond. So in the how would you like ChatGPT to respond column, I'm going to paste, you are a garden gnome that writes whimsical and highly informative poems about boring topics in computer programming and business. So I want it to rhyme, I want it to be fun, but I also want it to be precise and accurate. So if I do this and then start a new chat, we can see if I ask some basic question, like what are trends in database technology? We'll be able to see that instead of responding before like it did, like it was some kind of like listicle blog article or some very like vanilla kind of way that the internet reading ChatGPT you'd expect it to respond. Now it's like kind of immediately doing this whole different way of writing where it's actually kind of like listening to that system message. It's writing poems, there's rhyming, a lot of it's like referencing things from nature. So it's kind of getting into this like interesting way of interacting with the system where like obviously for most use cases, like you don't want your products to be talking to users like a garden gnome. However, like it points out that you can put guides on even just the ChatGPT interface itself to sort of change how it does things. Like a good example is like if you get annoyed by it saying like, I wasn't trained on that data, it's like I've only been trained to 2021, you can kind of get it to like behave in different ways in the face of not actually having the information that you're asking questions about, or sort of like responding in different ways when you ask it about maybe a politically sensitive topic that obviously OpenAI has kind of put guardrails around ChatGPT that it doesn't want you to answer. Things like this are kind of useful ways to think about this system messages idea. Now, zooming out again, like there's also this whole world of prompt engineering, which is basically taking ideas like system messages, so like the thing that we just saw in the actual interface, and then bringing them into the programs that we write around these APIs, whether it's the open source Bloom model, the Llama 2, or it's the OpenAI API, like we saw in the last notebook. So one of the key frameworks right now that's been super trendy over the last year is called LangChain. And LangChain has like many, many different parts to it, but this is one of the core things that I think got LangChain really popular, is that it's basically a framework for doing this kind of, this kind of templating of your prompts. So for people who are familiar with writing Python code, it's not too different from string formatting. Or for people maybe who are more into kind of the SQL world, it's quite like Jinja templating as well. So to get started with this, we can go ahead and install LangChain. And then I'll just briefly walk through this little snippet of code here, where we're going to import the chat prompt template and the chat OpenAI template. And they have matching templates for things like Hugging Face models as well. So if you want to do this with the totally open source framework as well, you absolutely can. And I suggest that you do play around with that as well, because it's quite interesting to see how some of these smaller, less powerful models behave when you prompt them in this way. Now, the actual template that we're going to have is you are a helpful assistant that translates input language to output language. So these are the kind of templated strings. With many years of experience of teaching language to beginner students. Cool. And then we're going to have the human template, which this is the thing that's like what I'm actually typing into the ChatGPT interface. And this template part is kind of like what's going into that system message box that we just saw in the interface. If we do this, then we instantiate our chat template and the actual chat object itself, which is what we need to pass the OpenAI key to in LangChain. And we can sort of quickly get this kind of interface here where we have like a response coming from the chat, and we can translate something into different languages. Like here we see the result that it's kind of from me doing it to German before, but you can just change these things around. So maybe to make this even more streamlined, we can just write a quick function like inputs, outputs, and then text. And then move this over here, and we'll actually return the content. And then we'll just templatize all of this. So we have input, and then we'll match the output language. And again, this is coming from our template up here, the input and the output. And then we'll put our text here. Now I'll take this thing and put it into my terminal. So like this is, again, this is like, you don't have to follow along with this part. You can use the notebook. You can kind of do whatever you want in the terminal. I'm just going to show you this to make the demo a little bit quicker. Now we basically have something kind of like a Google Translate API where I can type translate. My input language is English. My output language, we'll say Spanish. And then, Ville, do you have any ideas for something we want ChatGPT to translate for us?
Like, unfortunately, my Spanish is limited to Mexican food, so.
Okay, well, in that case, we'll say, like, I would like 2 burritos, please. Correctly. So let's see if it can translate this into Spanish for us. Me gustaría 2 burritos, por favor. So pretty nice. It's pretty streamlined.
Sounds accurate.
Maybe we can, since you don't know Spanish, maybe we can ask the same question in Finnish then, and we'll see. Is this reasonably accurate? I'll make it bigger.
Oh yeah, no, that is perfect. Yeah.
Cool.
Yeah.
Nice. So now, like another superpower kind of what we've done here is we can say translate from Finnish into Spanish. And we can see how good sort of the whole end-to-end situation is going. It's like, this is pretty good. I want 2 burritos, please. So we can kind of see like we've built some API that's like maybe not as good as like the Google Translate, but it's something that we can use in our code very fast. And it's very like high level kind of interface that we've put together using this prompt templating idea. Cool. Now I won't like spend too much more time on prompt engineering because we have a lot more to cover, and I realize we're already an hour 15 in. But in the bottom of this notebook, there's a whole bunch of ideas that have been proposed, I suppose, in the community, like the research community around prompt engineering. It's a super like hot area of data science research, and it goes well beyond just this like basic like programmatic templating idea of like actually changing how you communicate with these LLMs in a way that's like much closer to how humans reason to solve tasks. So feel free to check out any of these papers. There's code attached to some of them. Yeah, there's a whole bunch of interesting activity is really all I wanted to point out with all of these different links. So a lot to check out and a lot to pay attention to if you'd like. I think now before we move into the retrieval augmented generation piece, there was some more slides. Is that right, Ville? Should we go back to the slide deck?
Yeah, I can just say a few words about that.
Awesome.
Yeah, if you go to the next slide, there's so this one. So now, like what Eddie was showing here with all the system prompting, you can see that your like imagination is the limit, like what you could put there, like as a prompt. And now, one interesting like use case is, of course, the case like where you may have new data and changing data that like you want to input to the model. And then, of course, like that brings the question that like you might actually like have a tons of data that you potentially would like the model to know about. And like, of course, like a classical use case may be that imagine that like you have your like a whole like a company's knowledge base, like a whole like a company intranet. And like maybe you would like the LLM to know everything that's going on in your company, including all the recent Slack messages and so forth. So then, of course, the question becomes that, well, I mean, I guess like you could just dump everything in the prompt, like have I don't know, like 100 gigabytes of data in the prompt, but I mean, realistically, that's not going to work. I mean, the models are not even able to parse so much data, so that's not going to work. So now the model and the idea with this retrieval augmented generation is this idea that you can see that we have this kind of context DB here. So we have some kind of database that contains information that we deem that would be potentially useful for the model to know. It's almost like kind of a database of all kinds of prompts, all kinds of additional information that like we could like kind of like give to the model. But now, Eddie, if you go to the next slide, we have this interesting problem, as always with databases, is that we have this like infinite library of all kinds of things, but what on earth like should we actually like put in the prompt? So I mean, given that we can't put everything in the database, we somehow have to choose like what we want to put in the prompt from the database. And now this is basically, of course, like that gave an explosion to this whole idea here about vector databases. And now, like with the vector databases, like the basic idea is exactly this, that we have a database of documents. We have a database of, well, unstructured like information, but I mean, let's say like natural language. And now the kind of roughly the idea, and like, which is kind of a bit hazy, like kind of like how it even like would work. But roughly the idea would be that like we have some kind of like a hint or like this like a seed, like what kind of information we are interested in querying like from the model. And then like we use vector DB to find similar information, kind of like relevant, supposedly relevant information that is related to the query at hand. And then like we hence like select a subset of documents that we can then pass on to the model. And that's basically all there is to this like RAG idea that it has been super popular lately. And of course, like why there are so many vector DB companies around. So the basic idea is very much like as shown in this diagram, that like we put all the documents in the vector DB. And now in order to be able to do the similarity search, in order to be able to find the similar documents quickly, like we actually convert this document to a vector representation. So we kind of put them in this like a mathematical space so that like documents that are supposedly like related to each other are kind of nearby. And then like what we can do is that then when we get the prompt, we can like create a vector for the prompt, and then like in that space, simply see like what are some neighboring points in that space, what are some neighboring vectors, and then decide like how many of these neighboring documents, other similar documents, we would like to retrieve and like put in the prompt. And of course, this idea of similarity search and document search like in the vector space is of course like actually like not specific to LLMs. People have been doing this for a long time. But given that like we have this very specific problem that like we would like to enhance our prompts with some relevant information, this kind of approach like just happens to be kind of like a nail in the head, kind of a good solution like for like this particular problem at hand. So I think that that's like kind of all there is to say about this basic idea. And given that the basic idea is actually like not that complicated, although there are like a fancy words like vector DBs and like RAG and so forth, it's actually like not that complicated as Eddie will show next.
Cool. So yeah, we'll move through this next notebook really fast because as Ville said, like the idea is not super new. Like most people familiar with data science have been doing stuff like this kind of since the beginning of being exposed to NLP. But yeah, so the basic life cycle we have is kind of like we want to chunk the unstructured data. We want to compute embeddings on these different chunks of data, which in this case is text data. Then we want to index the embeddings based on queries. Run a similarity search against the embeddings, and then kind of use those vectors somehow in our prompt. Now, one thing I'm realizing is that I have kind of an old version of this page in my sandbox. So what I'm going to do is actually go to the GitHub repository here and see if I can just copy and paste some of the stuff from here. Yeah, so like in the not stale version of this sandbox workspace, which I hope most of you have gotten in your sandbox, we kind of have an illustration here of many of the different vector database providers out there. Like Milvus has been around for a while, Weaviate, LanceDB are some good open source options. And then in our case, we're going to use Pinecone, which is another enterprise provider. So I'll kind of show you how to do similar to OpenAI, like go to their website and get an API key for Pinecone. And then we'll be able to use Pinecone to kind of send vectors over the network to their database and then query them and like have Pinecone kind of do the similarity search on its side. But yeah, important to know that there's a lot of these different providers and they all generally do the same job, but there's also a lot of really interesting nuances for people who are kind of more into the database world and really want to understand these different frameworks. Cool. So
let's. So Eddie, by the way, there was a question on chat, like a fun question, that like, why does everyone use Pinecone versus other vector DBs?
That's a great question. I am definitely not an expert in this realm, so I'm curious what you have to say, Ville, as well. For one, I think.
Well, I mean, first,
yeah, go ahead.
Yeah, go for it.
Yeah, I mean, for one, I think Pinecone is just quite a good company, actually. Like, they have really good content around how to use their service effectively. It does what it says it does. It's easy to use. Like, we can see if we navigate over to their API. Their console is just like quite snappy. It works well. And then the core database technology just works. That's sort of the thrust of like, why did I choose them for this project? But yeah, I'm curious if you have anything more insightful, I suppose.
But Eddie, I guess it's fair to say that like probably like technically it's not that there's like any kind of like a super magical like happening in any of these vector DBs, in the sense that there would be somehow that the Pinecone results are better than the Weaviate results are better than Lance results. So I mean, at the end of the day, it is the same dot product in all cases, right? So.
Yeah, exactly. I mean, there might be some variance in like kind of what similarity algorithms are supported by these different frameworks, and there's kind of some features that are specific to different frameworks, like you mentioned, Lance. Like, they have more support for like multimodal things. Like, if you want to also do this kind of querying over images, they have things like this. It's like it's like embedded into your Python system, so it's not calling an API over the network, which like that could be another concern. Is like, even if these are just like embedded vectors of our content, maybe we don't want to send them to Pinecone for whatever business reason. So yeah, sure, there's like a bunch of nuance like that, but yeah, to Ville's point, they're basically doing the same job from my point of view as a data scientist, in terms of just somewhere to store these vectors and then search through them so that we can retrieve it and put them in our prompts effectively, or do whatever we want in a recommender system, say, with them. Cool. So this page here, I'm on my API keys page in the Pinecone interface. Again, if you just Google like Pinecone API key, you'll find the way to click in here. You can create a new API key if you'd like. I'm going to go ahead and copy mine. And then the thing that we're going to be doing in this interface before I go back to the sandbox is we're going to want to create an index, and then that's where we're going to put our vectors into that index, and then we'll search them. So with Pinecone, I don't think there should be any difference between my situation and yours, because I'm not on a paid plan or anything in Pinecone. And you can make one index for free in Pinecone for testing things out. Cool. So let me just go ahead and set the Pinecone API key. I need to do it as a string, so this will yell at me. Cool. Again, like, this is not a good practice to do in like a production setting or with like a not free account that's for demo purpose. And Metaflow has a bunch of nice features that can help you not just like paste your API keys into Python like this. Anyways, the other thing that we're going to need to set, I see, I already have mine here. The other thing that we're going to need to set is this environment, which this is unique to how you deployed Pinecone. So you'll see here that mine is in US Central 1. These are just like maybe availability zones, if you're familiar with AWS terminology. But you don't need to know much about it. It's just like, where does the actual computer that's running your Pinecone index live? So let's copy and paste the environment. Awesome. Cool. There's some extra packages that we'll install here. So this one here, the RAG demo, this is the only one that's kind of custom thing. We put together a blog post that's kind of explaining this RAG stuff in more detail than we're going into here. So if you're curious about that, you can go to outerbounds.com/blogs. But as part of that, we made this RAG demo repository, which has just a few tools for parsing markdown files and like actually gathering the data that we're going to use in this example. So I'll go ahead and run that. And then again, since I have this old notebook that's going to look a little bit different than yours, what I'm going to do is go to GitHub and actually just start copy and pasting stuff from there. Because there, before we get into the like bigger use case, which is chunking up the Metaflow documentation and indexing it, we're just going to start by doing one little sample first. So we'll first import Pinecone and then kind of set up some variables like the index name. And then this metric is what Ville was mentioning earlier about the similarity searching. So there's several metrics that you can pick from with all these vector DBs. I think Pinecone has 3 or something like this. But cosine similarity is just basically one way to do kind of a vector dot product that measures how similar 2 vectors are. So going back to our terminal here, I'll go ahead and paste those variables in. Now, let me make this a little bigger. Using this custom tool that we've put together, we made a little interface that essentially exposes, like it's not that much code that it's hiding, but it just gives you a little bit higher level interface for choosing any of these sentence transformers embedding models, which this is also coming from Hugging Face. So it'll look exactly like when we went to the interface before and we saw like, oh, there's thousands of models we can shop through. I think there's maybe not thousands, but there's like hundreds of these different sentence transformer models that you can use to produce embeddings. So I'll just go ahead and copy and paste this whole cell. And well, that's
well, it is.
Go ahead.
Yeah, I was just like, again, I mean, like for those of you who are doing this for the first time, the idea, and like, I mean, like if you are not familiar with the term embedding, the idea is simply that what we need to do in order to find these documents in a vector DB is that we have to convert the documents to vectors. And actually, like we use large language models themselves to do this, like from document to vector conversion, and that vector is called an embedding. And that's something that we have to do outside the vector DB. The vector DB is not going to do that for us. So like we are responsible for actually producing the vectors to kind of to actually insert in the vector DB, which is exactly what's happening now here. Just wanted to clarify that part.
Yeah, that's a really good point. Like one thing too, you'll realize is like OpenAI has their own embeddings API as well. And like it's also using a different language model is what they suggest typically. It's like maybe you're going to do the LLM generation part with GPT-4, and they'll suggest that you use a different model to produce these embeddings. So it's important to realize that these are kind of decoupled parts of the system, because these things that are going into the vector database, these embeddings they're not like mathematically necessarily connected to the LLM part. But there's also just a bunch of different APIs, both open source and commercial, much like earlier with the LLM inference part. Cool, so I'll get rid of this and just clear up some browser space. And then to Ville's point, like we had these text samples that we're using to guide this example. So the first one, just sample. The first one is hello Gen AI friends. And then we've produced these embeddings. So I'll take the embedding and to see how many there are. So we have 3 embeddings, and each of them is a vector with 384 numbers in it. So the first one is going to be this corresponding to this piece of text. And we see like, I don't know how to make any meaning of this, but it's just a big long list of 384 numbers. So all we're doing is like putting this somewhere into Pinecone, and then that's what's being searched using that similarity metric that we defined above. So now continuing with this example, we'll go ahead and create our index in Pinecone, which this will take a minute, I believe. Oops. What did I need to do here? Okay, let's see what I've got. Index name, Gen AI Summit test, the dimension, 384. And then what is our metric? It's fine. On live debugging. I may just skip this part if it's going to be hard to figure out. Let me see. Maybe I already have an index here.
I wonder you could maybe just instead of using those variables, I mean, just type the strings like in that command by hand.
That's probably a good call.
Like really should work. So
yeah, I don't think there's anything crazy going on here. Now the dimension, we had 384, and then the index name was AI Summit, something like this. Oh, it's probably because of the hyphens or something like that. Oh, I haven't seen this one before. So I think maybe just go ahead and skip through this section. Sorry about that, folks. I can also check here.
Actually, like one like a crazy idea, because it says the expected string. So can you make the dimension a string as well? I mean, could it be that?
Oh yeah.
Because it's an integer. So.
Right.
No. Okay.
Yeah, I don't know. Good idea. I'm not sure. I haven't seen this one before. I wonder what I missed here.
I guess
Live
here's the reason why. Yeah.
One thing we can try too is just to like see if any of these APIs are working. Okay, so it looks like maybe my API key is not correctly specified, I'm guessing. Go back here. And then I'll copy this value. And reinitialize Pinecone. This is the last chance, and then I'll spare everybody my trying to figure this out. Okay. And see if we can do anything. There we go. Okay, so now it looks like we can do something useful. Go ahead and create the index. And then I think we should go over here and we should be able to see some kind of loading pattern. So now we see our Gen AI Summit test Pinecone index being created. This will take like less than a minute, I think. Shouldn't be too long. It has its own URL, just like an S3 bucket. And then there's a bunch of interesting information here too from Pinecone that you can find like even more if you sort of click into it, or you can actually also like programmatically connect directly to the instance. So that'll just take a minute, and then I'll start walking through a little bit like what we're going to do with the index. So remember that we had 3 vectors in this text sample object, and we had 3 embeddings corresponding to each of those. So we want to upsert documents into the index, and Pinecone has a very easy API for doing this. This is maybe another thing to look at when you compare these different vector database tools, is like what kind of database patterns you're going to be using. So like this is no different than a regular kind of SQL database that you might be like kind of shopping for different options. It's very important to think about your access pattern for the data, and then also your uploading pattern. So nothing really changes there. This is like very basic kind of database, like a database use case. So we can see now that our thing is created. So good, we have the green dot. Now we can go ahead and actually access our index. And this is what's going to allow us to do the vector retrieval part of things. I'll go ahead and just upsert these documents. Move through this section very quickly. And now for our, like this is kind of now like moving into the runtime section. So we have our vectors inside the database. We've sent the embeddings with those numbers in them. And now what we want to do is we want to have some sample. So this is like maybe something a user types into your application. What does Metaflow do? We want to embed that using the same encoder, which is this embedding model here from Hugging Face, the same one that we use to embed the vectors in the index. And then we're going to match them using the Pinecone API. So I'll just go ahead and do this, and then we can see what the result looks like. We can see it was super fast. Whoa. Super fast in the terminal. And then if we just print out these matches, we can see that we have kind of these dictionary objects being returned, where the first one is going to have the highest score. So this is the actual cosine similarity score, because the metric that we chose for our index is cosine. And then we also have like the other metadata that we included, which in this case, we chose to add the text as metadata here. So we kind of have this loop now of like a ranking of the top K results in our database, which in this case, we chose K to be 3, and we only had 3 examples in the database, is why we kind of see everything get returned here. But you'll notice that it's rank ordered. And this is kind of a nice feature of using Pinecone to answer the question from earlier as well, is that Pinecone has a pretty good API for like how it returns data to you in your applications like this. Cool. So that's the basic use case. Now, for time reasons, I'm actually going to kind of just explain what's happening in the rest of this notebook and then move into the next section, which is, I think, more important to kind of complete the loop of this talk. But we've basically written this thing in the RAG tools repository that allows us to easily kind of parse markdown files, which the documentation for Metaflow is written in Markdown files. So if you go to this GitHub repository, Netflix/Metaflow docs, you'll see what I'm talking about. That actually is producing the documentation, which we see here. And so these are all Markdown files, basically, is what's happening. And we're going to chunk them based on the header sections. And the goal there is basically to like put all of those different header sections into the vector index like we just did, and then have this pinecone index that we can search in our RAG applications and use to kind of give LLMs actual information about Metaflow according to the documentation. And since it's connected to the GitHub repository in this RAG tools thing, we can kind of just run this whenever we want, and we'll always have like fresh data based on what's existing on the Metaflow documentation. So to keep moving along, like I'm not going to gloss over and actually run this stuff down here, but it's the same pattern that we just saw with the few basic examples where we create the index. Then we're going to have a bunch of documents get upserted, and then we can start asking questions. So I think in my old notebook here, I might even have the outputs, which we can see. Yeah, so you can see now an example of the runtime querying with k equal to 5. We can see now that like basically what I'm pulling in here is a bunch of different row indexes that are connected to all the different sections of the Metaflow documentation. So then using those indexes, we can do something like create a pandas data frame of the 5 most relevant results based on the user query in our notebook, which in this case was, how do I specify conda dependencies in my flow? So we're returning like the most relevant documents from Metaflow's actual documentation in this data frame. And then these can be used as kind of seeds in our prompts, or some way that we want to unpack the context in our prompt that we give to OpenAI. So what we see down at the bottom of this notebook is basically just that happening. We're using kind of a lane chain-like pattern. We're not using Python strings, and we see the template getting constructed. And then when we do the chatbot loop with LangChain, then we can kind of see that the response that ChatGPT is giving is actually like correct information about how to use Metaflow to do this, which just to point out that like that would not happen if we didn't do the RAG piece of this. You can kind of see like this question doesn't say anything about Metaflow. So if I go over to ChatGPT and just delete this context prompt about the magical garden gnomes, and then start a new chat and ask it, how do I specify conda dependencies in my flow? ChatGPT is going to be very confused. Like it's not even going to know that we're talking about Metaflow. So if a user goes into our application and tries to type this, and we just use the vanilla ChatGPT, it's kind of hopeless that it's going to give useful information back without the RAG pipeline attached.
So Eddie,
yeah, go ahead.
But like back to the notebook, like I guess like one like kind of thing to double click on is the question that how do you actually then like take those RAG results? Okay, so we get this like a 3 closest documents from the vector DB now, and then you have this section like where you use them in the prompt. So how do you actually just add them in the prompt? Do you just like concatenate them like in the context, or like is there something magic going on?
Yeah, very good question. In general, yes, there are a lot of magic tricks that I've seen people trying. What's actually happening in this notebook is something very naive, I'd say. It's like we can just see that this is just a normal Python string, this system message. You're a helpful assistant that helps learners use Metaflow to build production-grade machine learning workflows, blah, blah, blah. That's just being put into this context template here. And then we have this other context object, and this is where we're actually unpacking the RAG results. And where that's happening is here. So we have this context object. It's an empty string. And then we're just looping through the results of that data frame that we saw that contained the 5 most relevant results. And we're appending to this string. Like here's another piece of context. And then we're also attaching some additional metadata, which is the URL to where that header actually exists in the Metaflow documentation. So like the reason that we were doing that, which like that's probably the most interesting part of what's happening here, is that this gives you something like if you're familiar with Bing or Perplexity AI is another of these like ChatGPT like things that's doing this. It's actually returning you real information based on a search like this that's like pointing you to other websites. So it's kind of like citing its sources in a sense, where you can like, not only is it indexing on information from Metaflow, Metaflow's documentation, but it's actually showing you exactly where in Metaflow's documentation it got that information from.
Nice. So on that point, Eddie, like Anas here like was asking that interesting case might be that instead of like using a vector database, let's say like we have a relational database and like we have some structured data. Let's say we have some table about maybe sales or something, and then like I guess like one could like insert that context in the same way in the prompt and say that okay, the sales in July was like a 50,000, and then say sales in August was 80,000. And then like you can ask questions like from the LLM in the same way, right?
Yeah, totally. There's a bunch of different ways that people are approaching that. Like, I mean, there's some people that are saying like the LLM itself is kind of writing the SQL queries, which maybe or maybe not that's useful. It might be very inefficient. It's kind of one point of view on this. But it also might help like kind of users who don't know how to use SQL, like access the information in the database. But then to the point of that question, there's also like, if you do a RAG like pipeline just over the SQL database, you can kind of just like, you can see where this is super flexible. You can program whatever you want in this loop and kind of construct the context that you give to the LLM in whatever way you'd like. So again, like the world is really your oyster, and like whatever kind of creativity you want to explore and how you like shove information into the prompt that you give the LLM. That's like a big area of research for many people.
Yeah, but I guess the downside is that there's really no guarantee like what the results will be. So I mean, I probably like wouldn't like replace my accountant with the prompt and like a dump like everything there and like ask that okay, can you do the kind of the profit and loss like based on this prompt? So who knows what would happen. So.
That's a very important thing to remember about RAG is like you're not fundamentally changing anything about the model. It's like it's still doing this kind of like auto-regressive kind of like hallucination based on what it's previously seen in the past to like get to what it thinks is most likely to come next. It's nothing intelligent happening beyond just like if you stuff a lot of stuff in the context, that's just changing the probabilities of what it's going to predict next, but not the actual mechanism.
Right, that's a good point. So Eddie, now I realized that we have only 15 minutes left and like so many amazing things to cover. So I was thinking that like maybe we just like breeze through the kind of the systems point of view, because I think that's of course really important part here, without even like going to so many details, and then like maybe we have a few minutes for the fine tuning. So there are the slides about the system. So maybe I'll cover them really quick and
yeah, that's perfect.
Like we can,
these last three are basically just the workflows, and like we can talk about that offline, or people can ask us questions about that. I think maybe we keep it at the concept layer and the slides for these, and then we can just show the serving part at the end. Does that make sense? All right, cool.
Sounds fun.
I will click through here.
So okay, right, and like well, anyway, I mean the kind of a whole like premise of this workshop is that what Eddie was showing here is of course super cool, and like we were able to kind of go through all these notebook cells by hand. But of course, I mean this is not exactly a production system. So now the big question is that like let's say you actually wanted to build a product, or you actually wanted to build a service around these concepts. How would you do it? So yeah, if you go to the next slide here, so like one really important thing to realize is that there are many moving parts. And now, for instance, like let's say in the like what the example that Anas made is that you have a relational database. So you may have, let's say, your company's knowledge base. That's the data warehouse here on the left. And you may have other systems that like, well, I mean, first like update in real time. Or let's say Eddie mentioned that we can index the Metaflow documentation that also like it changes relatively frequently. And hence, like we want to keep the vector DB up to date every time new data appears. So the first question is that like we kind of want to build this system that basically runs itself like every time like a new data is available. And Eddie, if you go to the next slide. So this was like, for instance, like one motivation for using a system like Metaflow that contains now this built-in functionality for being able to trigger these workflows whenever something external happens. And of course, there are like many other ways, like how you can do the triggering logic. Of course, the benefit of Metaflow is that it also allows you to address all the other parts in the stack that like you need to build a system like this. So now, if you go to the next slide, this slide kind of conceptually like shows the whole setup. And actually, like I can put it on Slack. Oh, sorry, I mean on the chat again here. like you can check out that repo and the blog article to kind of see the whole picture. But basically the system we would like to be building is that here at the bottom, like you see the workflow that basically has the kind of some like a starting point whenever new data appears. And then like the important part is that like we want to create these embeddings that scale. So you may remember like when Eddie was quickly showing how we created these embeddings like in a cell, and it took a few seconds. So now you imagine that if you have, let's say, 1 million documents that you need to create embeddings for, that's going to take 1 million seconds. 1 million seconds is kind of a long time. So now, of course, like what you can do there is that you can parallelize that compute, that instead of doing it on your notebook or like even doing it on a one server, you can maybe have 100 servers doing it in parallel, and then it takes only like 3 hours in total with 100 servers. So that's going to be way faster. And then, of course, there's the question that like, how do we scale up that compute? And then like with those embeddings, like we can populate the vector DB, and like we can do all the other rack parts that Eddie was showing. So if you go to the next slide, just conceptually, and like Eddie, maybe you can like just quickly then like show like in a few minutes like what it looks like in practice. But the idea here is that like in our demo repo here, like we have kind of like 3 workflows that are interconnected. The first one is the part that actually retrieves the data from our hypothetical data warehouse, which happens to be the kind of the Metaflow documentation in this case. And then that thing in turn like triggers this pre-processing flow that then like triggers the one that actually like populates the vector DB index. And of course, that part is kind of compute intensive. And Eddie, if you just go to the next slide really quickly, I wanted to highlight a few features just to motivate like why you may want to consider Metaflow for this use case. Is that, for instance, like for the first thing, I mean, there's the first question at the very top, like you see the add schedule, which is that, okay, how should you run this workflow? And as I mentioned, you could connect that directly to the data source so that it runs automatically whenever new data appears. You can use this feature called event triggering. You can read more about it in the documentation, or you can, of course, like run it like based on some time, that like every once a day or like every week you run this workflow. Now, a couple of other things that are like worth highlighting here is that like for each one of these steps that we are executing, we can specify explicitly like how much resources we want to use. So for instance, we can say that, well, I mean, maybe to parse the markdown, we need 8 gigabytes of memory, and like then Metaflow makes it available. Or like, let's say like we know that there's a specific Docker image we want to use. Like in this case, we have like Eddie created an image in Docker Hub that like that contains all the dependencies. And then Eddie, if you go to the next one, like in the kind of the pre-processing flow, for instance, we have different parameters. And like now, of course, like when it comes to experiment tracking, Metaflow automatically keeps track of all these parameters, like all the artifacts, everything that goes on in the flow. So that happens automatically. And you can see at the top where it says like trigger on finish, it means that like whenever that markdown part is finished, then this data table pre-processing flow runs automatically. So that's pretty cool. And a small detail, like at the start step, like what you can see there is this at card, which then takes care of actually creating a visualization of like everything that's going on. So you get that like observability in production, so you can like eyeball that everything is working correctly. And so I guess there was like one more slide, but basically kind of the similar ideas here. I guess like one thing that's worth highlighting on this slide is that we can also use different Docker images. So as a minor detail, in a complex production system, like the dependency management by itself becomes a big issue, and Metaflow has many different functions for having like a PyPy packages, Conda packages, or using different Docker images, so you can kind of manage that like kind of a complex mess with some sanity. So yeah, so maybe like a next slide as well, so I can just like kind of cut the chase and like kind of show the big picture. So like really the end result of like when you put all these pieces together conceptually is that at the very top you have some database, like where the data lives, and then like you want to load fresh data, like whenever like a fresh data is available, you want to create these embeddings at scale because it takes some amount of compute power like to do that, and then you want to populate the vector DB, and you can do all of this using open source large language model if you so wish, and then like Metaflow can like help you manage this whole compute cluster behind the scenes. And then of course like then like once you have the vector DB, once you have the open source model, everything set up, like then you can have this like real-time layer as well, like wherever like the customer like sends the prompts, then it queries the vector DB, it queries the open source model, and then like kind of produces the final result. So that's kind of the end result here. So Eddie, I don't know, like if you want to breeze through like kind of in 5 minutes, so maybe then we have 5 minutes for the fine tunings.
Yeah, sounds good. I think maybe what I'll do is, since Ville already showed basically the outline of these different workflows, I'm just not really going to talk much about the workflows, and I'll go into the observability layer where we can kind of see the results of executing this chain of workflows that he showed. So if I go into the Metaflow UI, we'll be able to see kind of the results of me running stuff in this sandbox. So when you get your sandbox, you'll also have this kind of Argo deployment that's running in the background. So if you don't know about Argo, no worries. This is kind of like the production orchestrator that we use. So you can run these Metaflow workflows locally or on Argo with no code change. And actually, when you hit these deploy workflow buttons, that's the command that's running is deploying this markdown chunker, for example, to Argo.
Eddie, by the way, to be painfully obvious, like how did you get to this Metaflow UI?
Yeah, that's a great point. This button here, this thing with the kind of the horizontal lines, this is the Metaflow UI. There's a couple other things here too, like we have a special kind of card visualizer, and then we have this Argo workflows UI as well, if you prefer that view. But the Metaflow UI actually contains kind of a superset of the information of Argo. So I think since we're moving fast, it's good to just kind of start there. And stick here for this session. But basically what we see here is we had this markdown chunker flow. We've actually run it twice. So one difference you'll notice here is like this one has a different kind of ID. This one was run locally on the sandbox. This one was run on the Argo workflows deployment. And then we see that triggered this ID here, that triggered this data table processor, just like in the kind of the arrows in the slide that Ville showed. And then similarly, this ID here of the data table processor, this triggered the pinecone vector indexer flow. So not too much to add here, other than like as Ville pointed out, this one's more compute intensive. So we needed kind of this create index step ran for 1:21, much longer than the other ones because it's actually computing the embeddings using the Hugging Face code. And then maybe the other interesting point is just to see the result of the card object. So here we had in the data processing flow, we kind of have a realization of what that card decorator does in Metaflow, which kind of adds this visualization layer onto your experiment tracking, where we can see stuff like when we just chunk the markdown files, we have a bunch of stuff that has kind of like very low amounts of characters, very low amounts of words. And then after we do the filtering, we kind of have a better distribution where like we have at least 10 words in all of the different chunks that we're actually choosing to turn into vectors in our index. Then like the least interesting histogram of all time, because we're only actually using one website in this case, but this repo is kind of written in a general way where you can have like many different repositories indexed like this. So I think that's pretty much it for kind of the conceptual layer, but definitely try these out. Let us know how it goes for you. You have a full Argo deployment in your sandbox, which I think is pretty awesome tool that you have at your disposal. Yeah, and we'd be happy to kind of help you out if you get stuck on anything.
Yeah, and by the way, like just quickly before we move on, I can just put the Slack again. So please join our Metaflow community Slack. There are over 3,000 people there, so you won't be alone. And like the UI and like everything else you saw here, it's open source. Like you can deploy it in your environment. Of course, then like what we do at Outerbounds is that like if you actually like want to get the production quality environment, like we can provide it as a managed service that like runs on your cloud account. So if you really want to do this seriously, but I mean, definitely like you can try all these things at home, like in open source. So that should be fun. And of course, like now, maybe last but not least, I mean, like we can cover the fine tuning in a couple of minutes.
Cool. Okay, I'll just start doing a whirlwind in the Git repository and stop me or interrupt as you see fit there. So there's a couple little like things at the end of this repo that are not in your sandbox. The fine tuning, the Llama 2 fine tuning, and the Llama 2 serving folders. So in the fine tuning, we have a workflow with Metaflow. We have some model code, which this is like not too different from just some Colab notebook I found on the internet. But we see kind of the same sort of like get your model from pre-trained using the Hugging Face API, get your tokenizer. We're doing some fancy optimization stuff for people who are studying fine tuning these days using QLoRa, and then just creating a Hugging Face trainer, not not too difficult PyTorch code to understand, or excuse me, Hugging Face code to understand, instantiating our trainer, and then training it. Crucially, we're saving the model at the end of this training script. And then just to keep moving super fast here, we have sort of this regular looking Metaflow flow object where the interesting step that we have in the workflow is this train function, where we're actually calling the main function from that model script. And then the saved model that we're using, we're kind of zipping that up, compressing it, putting it into S3, and then we'll show you how that's getting pulled onto the server in 1 second to actually like host our own endpoint. So much like we're like querying this OpenAI endpoint from our Python notebooks, we can also like use our own NVIDIA GPUs or rent them in the cloud and then run the model itself if we want to really own this full open source stack and run the inference, like not on like a small computer like the sandbox that we saw with Bloom, but we want to run it like a big model. Like Llama 2 has like at least 7 billion parameters. So it's just not going to fit on the sandbox. So we'll show you how to do that in a second. Before I move there, Ville, is there anything you'd want to say maybe about some of the Metaflow code here, some of these decorators?
Yeah, well, I mean, many details here. I guess we don't have time. Maybe at like one point where you have the, like, is that line 40, you have the Kubernetes. Can you say anything about the hardware requirements for this one?
Yeah, so since we're doing a lot of optimization tricks, we actually can run this on a single GPU just to make it go faster. We've been running it on multiple. So you can kind of see like one of the powers of Metaflow is that we can change quickly between 1 GPU, 6 GPUs, 4 GPUs, however many we have the ability to access, given the nature of our Metaflow deployment. And then, of course, like issues like how much RAM is on the computer that we need are important for things like when you're downloading Hugging Face models and things like this. A lot more interesting stuff that we're glossing over clearly here. But I want to quickly get into this serving part, which I think kind of like completes the story more end to end than focusing on fine tuning right now. Because once we've fine tuned our own version of this model, it's like it's not very useful if we can't make our own API, kind of like how we were using the Cohere or the OpenAI previously. So we've been working with some of the folks on the NVIDIA Triton team to kind of put together a POC of how we can connect this Metaflow Outerbounds workflow onto actually serving the model using kind of the cutting edge way that NVIDIA suggests that you host these models on their GPUs. So looking into this repository, we have just a structure that's specific to the Triton server that you don't need to worry about too much. But we'll see it's connected to a Metaflow run ID. And then we're actually pulling the resulted compressed model from that workflow onto the server. And then we have the kind of the format of the prompts based on how we tuned the model in our instruction tuning data set. And we're just going to kind of unpack it. And then we're going to have the model be waiting on the server, ready for us to make inferences against. So I've already kind of prepackaged this much like a cooking show where I have 2 different views of a Docker container open here. One of them on the left here is running the server. It's just a bunch of logs that are not that interesting to watch. And then we have just a Python terminal open, which is able to query against that API. So we can type in basic questions, like a prompt. Like I think our one from earlier is like, how do I specify conda dependencies in Metaflow? See what this, again, this is a fine-tuned version of Llama 2. It's not doing any kind of RAG thing. And then part of the script that you'll find in that server part of the Git repository has code for actually running inferences. So making the request to the Triton inference server. So we can see like pretty fast there, like 3 seconds maybe. We got a response from our Llama 2 model. And we can see that it totally hallucinated an answer that doesn't make any sense. But the language modeling part is like reasonable. And then this is where we would want to kind of bring our own RAG pipeline back into the mix with our open source model, much like we saw in the later lessons of the workshops today. Yeah,
and I guess like just to complete the story here, now I think in many ways you can think that the RAG approach that we showed and then this fine tuning, they are complementary. So for instance, I don't think that it would be very feasible to fine tune the model, let's say, to always have the latest data. So it's much easier to do that on the RAG side. But then on the other hand, like when you really want to control the hallucinations and let's say like the Anna's example about, let's say you wanted to have a model that can really talk about the sales numbers, like from a structured database. Sounds like a really good use case for fine tuning, where you can actually like really have your own instruction set that like it determines that like how the model is supposed to respond to these different type of queries about structured data. So that would be an excellent use case where you potentially want to do both, kind of both the RAG as well as the fine tuning. So we are like pretty much at the time now. I do want to put one more link there. So we have many blog articles about fine tuning as well there in our blog. Definitely join Slack. Of course, like it goes without saying that Metaflow, that's the Metaflow repo. Go and start a repo, like and join the community. That should be fun. And by the way, on the compute front, like we will be making many more exciting announcements in a few weeks' time. How you can even do distributed training, how you can access GPUs in many different clouds, including CoreWeave, GCP, Azure, AWS, and so forth. So much more to come. But anyways, so any kind of a questions that you want to ask live? Like, thank you for all the questions you have been asking like during the workshop. But I mean now, so you have a few minutes to ask anything if anything pops into your mind. Yeah, thank you all, everybody for attending. And it is so that the repo will of course like stay alive. So if people want to follow the steps at their own pace at home, so they can do so, and the sandboxes will stay available. So and like we are there on Slack to help you. So if you have any questions, I mean definitely you can always find us there. And by the way, of course, goes without saying that for those of you who will be attending Generative AI Summit in Austin tomorrow and on Thursday, like we will be there, Eddie and myself will be at our Outerbounds booth. So if you happen to be in Austin, I mean, definitely come and say hi. Also, like, by the way, like, let me like quickly put that we are also organizing a happy hour on Wednesday. So again, like for those of you who happen to be in Austin, it would be lovely to see you in person with some snacks and drinks on Wednesday as well. So yeah, well, this was fun. So Eddie, anything else to add?
Yeah, nothing much. Hopefully we can meet some of you in person in Austin. But yeah, I appreciate everybody's attention, and feel free to ask any questions or anything at the booth, or hit us up on Slack.
Yeah, I'm just like commenting that yes. So I don't know if the conference is sold out, which sounds like a bummer. I guess this is a like popular topic, but the happy hour is not sold out yet. Although I mean we don't have infinite capacity there, so please do join the happy hour at least. So.
Oh,
yeah,
awesome.
Yeah, awesome. Well, Nancy, we will see you there. So.
Nice.
Cool. Well, in that case, like, yeah.
Oh, it does show.
Oh, like we need to. Oh,
we need to check the Luma link, maybe. I don't know.
Yeah. Well, I mean, definitely. I mean, Nancy, you should just like show up and like we will let you in. But no, I mean, we can fix the link as well.
Anybody who attended this talk, I think, should get into the Roaring Fork. That seems. Especially if they're still with us, Ville. I feel we need to make some kinds of exceptions here. Totally.
Thanks for staying with us so long. And anyway, so I think that's all for today. And see you on Slack, see you at the happy hour, see you at the conference, and overall, see you at the internet. So, cool. Bye all.
Bye.